Hello, this is Yakov, Fain. Can you see my screen? I hope you can. So today's presentation is about Angular. They used to call it Angular 2, now they decided to change versioning. So to avoid confusion, it's going to be called Angular. The older version of Angular is going to be referred to as AngularJS. As Paul already said, I'm consultant, trainer, author. This is our recent book. It's Angular 2 development with TypeScript. Now let's talk about the subject. Angular 2 and actually version 4 is coming out in March and in September 5 and so on. But the biggest difference was between Angular 1 and Angular 2. That was a complete rewrite. From now on, it's not a rewrite, it's just addition of new features. And Google created this framework and they keep working on it. And what is most important and the biggest difference comparing to super popular AngularJS, that Angular is a component-based framework. It's not an MVC framework, but a component-based framework. It has a very powerful modules for dependency injection, a really powerful module for routing when the user navigates on the client side by clicking on the links or doing other actions. Also, Google collaborated with Microsoft. Microsoft created originally the product called Reactive extensions for .NET, and then it became popular and it was ported to multiple different languages. And it is embedded inside the Angular framework, RxJS. Next, Angular collaborated with Microsoft in other area. In particular, TypeScript is a language, a superset of JavaScript. It was created by Microsoft, and Google had an arrangement with Microsoft, so they added additional features that Google needed, and the Angular framework itself is written in TypeScript. And TypeScript is really much more productive than just writing in JavaScript. It adds, of course, an extra step. You need to compile from TypeScript to JavaScript because browsers don't understand TypeScript and they will never do. But in general, we can see it in multiple projects that we work on. The TypeScript is a lot more productive. Technically, you can write Angular applications not only in TypeScript, you can write them in JavaScript, 2 flavors, ECMAScript ES5, or EX6 and probably ES7 that was finalized recently. There is a language called Dart created by Google. You can write applications in Dart for Angular, but the recommended language is TypeScript. And let's do a quick overview of what it is. Say you got a screenshot or PowerShop image from your designer that you need to develop a UI for, say, online auction. And this auction is supposed to have on the landing page, supposed to have a big image or a slider showing different products. Underneath, it's supposed to show featured products. And how do you approach it if you are a developer? If you are a developer, you need to decide what components are on this screen. How do you split the UI to the components? And in this case, you see that you can look at the screen as a set of components. I put this green border around certain areas, and each area is a separate component. Starting from top, there is an application component, the largest area in the orange actually, and then there is a search component, navbar component, carousel component, product item component, which in turn has a stars component. Underneath you see the footer component. Each of these components can be developed independently, and these components can communicate with each other. What is the component? How does it look? For example, if we will take the application, on the right hand side over here you see something that looks like HTML. It is HTML, but it's a mix of HTML and some tags that are not standard HTML, but rather representations of components that you or one of your developers created. Say auction navbar, the navbar of the auction. When I see this kind of a tag, I understand that apparently somewhere there is a component which is represented by this name. So on top of the UI of this window, we can see that we will have auction navbar. After that, some divs which are standard and auction search component, which is right on the left. Again, somebody developed that component in Angular. Over here, we see router outlet link. Router outlet tag defines the area where content may be changing. I'll talk in a minute about single page application, but for now just note that this area, which is surrounded with a navy blue border, is the place where we can show different things. For example, home view, which includes carousel and several products, or maybe if I will click on a product title, this area will render different component, like product detail. At the bottom you see auction footer. But this is all HTML, or as we call it, a template. Component has a template as a code, and the code. Now, where's the code? The code is right there. So technically, you create a component as a class. Let's look over here. Export default class app component. That's the name of the class. Inside you have some business logic that you will be programming, but to make a class, to turn a class into a component, you annotate it with special decorator at component. At component has selector, which defines the tags that somebody can use in HTML, the location of the template URL. If you have lots of HTML, it makes sense to keep it in a separate file. If the HTML is small, you can keep it in line. You may need to have some styling, CSS files, and you specify them there. And then the class itself with the business logic or functionality that you want to implement. In this example, we have this class written in TypeScript. What's the difference comparing to JavaScript? You can define types. In this case, I declare a variable product, and it's of type array, and this notation is called generics, and it means that we allow to store only objects of type product in our array. Then there is a constructor of this class. Constructor is executed once whenever the instance of this object is created. And as an example, inside of the constructor, we invoke a function getProduct on the product service. Where is the product service coming from? Who created it? Angular framework. It is injecting the instance of the product service right into our app component. I'll spend a bit more time talking about dependency injection in general. When the Angular framework was created, some people started to complain that there is too much to learn. We need to configure many different things, and to create a new application, it takes time. So Angular team created a tool that is called Angular CLI that allows you to jumpstart your project really quickly. I'll show you a quick example in a couple of minutes. But what this tool does is it basically creates a new component, new project for you, and it scaffolds the basic components. It creates configurations required for building the project, for deployment, for bundling it, scripts for testings, and you'll see it in a moment. So you can start really quickly with a new project. If you need to create new components or services, Angular CLI offers you simple command that you can run on the command line, and it'll add to your project new elements, new components, services, and so on. Angular CLI supports development and production builds. When you are working in development mode, you're not worrying about the size that much of the total bundle that represents your application. But when you will be preparing production builds, of course you want to make sure that your application is small. All that is supported by Angular CLI. Tests as well. Angular supports a couple, at least for now, unit testing frameworks such as Jasmine and Mocha. Angular supports end-to-end testing with the framework Protractor. And to run the tests, we use Karma runner, which is the most popular test runner that can be used with different frameworks, different testing frameworks. And now let me show you real quick how to create a new project with Angular. Let me do this. I'm in a directory. I already created one, but let me create another one. Let me do this. I have Angular CLI installed. So what I will do now, I will create a new project called Hello CLI. Oh, sorry, NG. The project will be called Hello CLI, but the command is ng new Hello CLI. Right now, Angular CLI created a bunch of files, as you can see. It created all these files. These are the starting files for your projects. They include not only the code, but it includes only the testing files, configuration files, and so on. At this point, it is installing dependencies for the Angular project from central repository called npm.js. There is a site npm.js.org that has 350,000 packages, and all Angular packages and their dependency are stored there. The whole process takes like maybe 30 seconds, and it's going to be done pretty soon. And after that, I will change the directory to Hello CLI. I will open it in the IDE, and I'll show you the code. Many IDEs support Angular CLI, really good one. See, it's done. So the project generation and installing all dependencies is done. Many IDEs support Angular and TypeScript development. The most popular are WebStorm and Visual Studio Code. WebStorm is not free, but it's really inexpensive. Visual Studio Code is free. Besides that, there are different plugins for different editors. So now what I will do now, I will cd to the directory Hello CLI that was created just now. ls, let me see what's in there. See, there are some files and some directories. Node modules in particular is a directory where all dependencies were installed. src is a directory where the source code, generated source code, was installed. So what I will do, I will open up the WebStorm IDE, and I'll show you the code. It's loading the project, and this is my project, Hello CLI. It was generated just now. I'll show you the content of the src directory for sources. As you can see, it generated for us a component for application, just one for now. It basically every Angular application consists of at least one module, which may have multiple components. In this case, it just generated for us. Of course, it doesn't know what or how many components do we need, but it created kind of a boilerplate project for us, assuming that I will have one component, app component. It also assumes that I'm going to need to work with the browser, which is a default module for any web application in Angular. Also, it assumes that I will be working with some forms probably, and it assumes that I will be making HTTP requests. That's why I need the HTTP module. App component itself, a typical component that is generated, may consist of up to 4 files. This one is app component TS, is the code in TypeScript. TS is for TypeScript. So what do we see here? What was generated? That is a class app component with a property title, and they assign the value app works. Also, annotation component tell us that component HTML is located in this file, and style sheets are there. So component HTML, if you will open up, it's pretty simple. It has just one header, one H1 HTML component, and there is a binding. The value of the property title will be bound here. Property title is in the code. So when we run this simple example, you will see the simple page which says app works. How do we run this example? I'm not going to go through all these configuration files. What I will do, I will open the terminal window. In Eclipse, not in Eclipse, sorry. In the WebStorm ID, you can have the terminal window right in the IDE, so you don't need to leave and go back to that command prompt window or terminal on Linux or Mac. Anyway, so I'm going to be entering the command ng-serve. What I want to say is I want to build the application and serve it to my browser. At this point, Angular CLI is bundling the application. Under the hood, it is using Webpack bundler, popular one. Now the whole thing is built in memory, and it tells me that it's running this application on the port 4200 on my local machine. So let me go there. Let me bring the browser on this screen. 1 second. And if I will enter localhost 4200, it'll load that bundle and see it prints me AppWorks. So in a minute, or maybe actually in about a minute, I have the ready-to-go application. Of course, you can say this is not a real application. Yes, it is not real, but it's a very good start. So if I would need to add something else to this application, I can either write it manually, or let me kill this server, or I can again use these Angular CLI commands. For example, if I want to create a new component, say product, again boilerplate for the component, I would be entering ng generate, or short G. What do I want to generate? The component. What's the name of the component? Product. Enter. Done. See, it generated for me several files. If you go back here, you will see that now I have another directory called product with all these files. If I want to generate a service is a class where you put business logic. So I will do ng generate S for service, say product service. Enter. And it generated from your class for product service. If you notice, some of the files that it generated have the extension spec.ts. It also generates files for unit testing. By default, it puts some simple stuff in there. For example, in the product, it's a boilerplate. Or in case of the application component, it even created a simple several scripts for unit testing to test different things. So this is how you work. You generate a new application using Angular CLI, and then you keep generating new components or services as need be. When the example that I just showed you a minute ago was building the application, the bundling it in memory. It was not for deployment in production. As a developer, you'll be technically creating this application, and then it builds the bundles in memory. You open up the browser, you see what is rendered, and you keep working in your IDE. As you change the code, the bundles are being rebuilt behind the scenes, and you see the new UI. All that is done in memory. If, say, I decide that this application is ready for production, so I will do actually a build, ng build. If I will do it just like that, it will not optimize my code, but it will keep it as is in terms of sizes, but it will generate files. In my previous run, everything was built in memory, but now it will generate files. But if I will add an additional key called prod, I want to create a build for production. So in this case, not only it will create files in the output directory called dist, but it also runs through several processes to optimize the code and to make the application smaller. When the build is ready, I'll show you the content of that directory that was created. It'll take another like 10-15 seconds. It is running optimization in this spot. Now it's done. It tells me which bundles it has created, and it tells their sizes. Their sizes, at least initial sizes. But if I will go here, you will see that it created a new folder called dist. All files are there. This is basically my application that exists now. If I will go to, let me do reveal in Finder, I want to see the files actually, their sizes. This is my directory that was created, and if I will check the sizes, you can see that it split the code into several bundles. The main one is here, it's pretty small, but there is another one which is vendor bundle. All Angular related code, actually all their code is bundled as a separate framework. So technically it's 360 kilobytes and 12 kilobytes from my code. If you will do a gzip of all these files, so if the entire application will be under 100 kilobytes, which is pretty decent size for the application, not too big. Now let's go back to the presentation. I'll review several other important components. Single page application, first of all, is a term that defines a web application that does not refresh the page as the user, the entire page as the user navigates. When I say it doesn't refresh, I mean it doesn't reload the entire page. It may load data for certain areas within the page, but not the entire page. You can look at a single page application as a collection of view state, home state, product detail state, shipping, and so on. And component router that comes with Angular allows you to navigate on the client side from one view to another within the single page application. When you design your application, you design components that will be statically rendered on the page, and they will stay on the same place or intact, but you will also define an area, this large one in this case, with the green border, the so-called router outlet. This is the area where you want to render different content. But say, for example, user clicks on the menu or on the links, and in this area you may display different components. The code of the components is already loaded, the page is not refreshed, but the data can be pulled in from the server to display whatever content you want in this router outlet. Main features of the router outlet are, first of all, you can pass data to route. For example, you look at the list of products, you click on the product, you want to display product details in that router outlet. So, and of course you need to pass the product ID that was selected, so you display the proper one. Child components, they can have their own route defined. Again, an application is a tree of components. The top level component, it's children may have their own children, and so on. You may have multiple router outlets, so on the same page you can designate different areas where the content can be changing. You can guard routes, pretty easy to do. For example, the user clicks on the link to open certain view. The question is the user authorized to see it? Is the user logged in? And so on. So you can create a class which serves as a guard. When the user tries to click on the link, that class will check authorization or maybe apply other rules, other business rules, and will either let you in or not. Lazy loading of modules is also implemented in Angular. When the user clicks on the link, what you may want to do, you may arrange modules for lazy loading when it is useful. Imagine that you have a page with multiple links, but some of these links are visited rarely. So instead of downloading the entire code base to the user's machine, which may take more time. You may download just the core functionality, and only if the user clicks on a particular link, decides to go to a certain route, then you will lazily load the rest of the code that is needed for this link. This allows you to make the initial downloads smaller for your application. Dependency injection is also very powerful in Angular. Every component has its own injector, and if you need to have an instance of the component, what you do is you just specify an argument in the constructor of the component of a certain type. And Angular is smart enough to understand, oh, they need product service apparently in this component, so it'll inject it for you. So you don't need to use a new statement to create instances. As an example, you can take a look at this service. Say this is a product service. It has a method gets products, and in a real world situation you would be placing HTTP request over here to get the product detail. For simplicity, I'm just hard coding the values, and I'm returning a new product. In any case, this is my business logic. This is the class that implements my business logic. So what do I do with this class? I marked it as injectable, and some component will use it. When I say component, I mean a class with a UI, with some UI. And this is a component. This is product component, and we inject product service in there. Injection is pretty easy. Basically, all you need to do, you need to define what you want to inject in the constructor, and you need to help Angular to say how do you want Angular to create it. I can't go into details because we are short in time, but providers tell Angular how to create instances of the components. But injection is happening over here only in one place, through the constructor. So the service is injected here, and we immediately invoke the method on this service called getProduct. We receive product, so we assign the product object to the product defined here, member variable of the class, and on the UI we bind different properties of the product, such as title, description, maybe price. So as soon as the data arrives and the product is populated, binding automatically will refresh your view, the HTML on the page. Intercomponent communications. Angular provides for there are means to arrange communication between components in a loosely coupled fashion. You can treat a component like a black box with some input doors and some output doors. You can mark some properties as @input. This is how the component can receive data from its parent. And you can mark some properties of the component as output. This is how a component can send the result of its activity to whoever is interested. And you can easily implement so-called mediator design pattern for arranging for loosely coupled communication. As an example, input properties, how it can look like. Say you have a component, order component. I didn't put HTML over here for simplicity. In there, I defined a couple of properties, quantity and stock symbol, and I marked each of them as @input. By doing this, I'm telling to Angular that I'm planning to receive data from the parent of order component, whoever it may be, through these two properties. The second one is actually a setter. The first one is just a variable, but regardless, the parent can have these values, can have these properties bound to parent's variable, and whenever something on the parent changes, these data will be updated. Output properties. Say we have another component called price quarter component. Imagine that the component receives some prices about stocks from some stock exchange, and every interval, in this case every 1,000 milliseconds or 1 second, it gets a new price on the stock with the symbol IBM. In this case, I am randomly generating price. Of course, it's a fake prices in this case, but it could be a realistic, say, WebSocket connection or something like this. And whenever the new price comes in, we want to emit this price. We want to send the price out. How do we do this? We declare a property on the component. In this case, I called it last price, and I marked it as an output. This property has to be of type event emitter. It's a special class that knows how to emit events. So whenever the new price comes in, we say this dot last price emit, and we emit an object. So not only we emit an event, but this event also can carry the values, the data. In this case, it's a price quote for IBM. If you want to arrange communication between different components, you can do it in several ways. Actually, implementing the mediator design pattern could be done differently, but one of the pretty powerful ways is by using some common injectable service. Imagine that you created an injectable service which has some properties inside, of course. It's just a class, and it can emit events. Now, let's say the UI of your application looks like this. And so obviously it's a diagram. I use all these shapes to represent the real business application, but technically you can imagine obviously that there are some containers on your UI which have components inside, and another container with two components and so on. So let's say the component number 5 needs to pass data to component number 6 and 8. The whole idea is that you can create these components like self-contained that don't know about other components that may or may not exist on the page. So what this component number 5, for example, number 5, say number 5 received some price quote, and it needs to notify about that price quote change to whoever is interested. Number 5 doesn't know who is interested. Number 5 just set the latest price on this injectable service that was injected in number 5, and injectable service fires an event, emits an event. On the other hand, we may have a component number 6 and a component number 8. This service is also injected into these components, and number 6 and number 8 subscribe to that event about price change. So whenever price changes, number 5 set it on the service fires event, and since it has 2 subscribers, they will receive the new price. And again, in this scenario, numbers 5, 6, and 8, they have no idea that each other exists. Loosely coupled communications. Really, really nice and powerful feature. Working with forms. Every enterprise application needs to have some kind of forms. And Angular offers 2 APIs, template-driven forms and reactive forms. Also, it offers some validators for like basic validators like required, minimum length, max length. You can apply regular expression. And you can create your custom validators and attach them to the fields on the form. This is an example of a template-driven form in Angular 2. It looks like a regular form with some HTML, but we want to do certain things. We want to intercept when the moment when the user click on the button submit, and you don't want to make any server request. We want to invoke our function that's supposed to handle it. So how to do that? Define the event that ng-submit in parentheses. Parentheses depicts event binding. So whenever, what we are saying, whenever this form ng-submit will be fired, then invoke the function onSubmit that you will write. For example, this is the function down there. And you want to be able to pass the entire content of the form, whatever user entered on the form. How to do that? In this example, we declare a variable. This pound sign, F. Pound indicates a local template variable. Technically, it gives you an access to the native element on the DOM in the browser where this form was created. From now on, you can say f.value, and this property value will have an object with all these fields and their values. So usernames of social security, password, and password confirm will be given as an object to the processing function, on submit in this case. Pretty simple to do. There is another so-called reactive forms API. It's a little bit different. but it's also very powerful and not difficult to use. If you want to create custom validators on the form, you can easily do that as well. What is a validator for a form control field? It's a function. In this case, I want to create a validator for social security number, unique number that every American has. And what do I want to do? I want to say, give me the form control. This validator will be attached to some form control, right? And what do? I get the value from the form, and in this particular case, I am using regular expression. This regular expression says that this field is supposed to have only 9 digits. And if this is the case, if the user entered 9 digits, then I assume that the value is correct, and I return null. If I don't return an object from the validator, it's a good sign. It means that there is no error. If I would return an object, it means that there were some validation errors, and the object will contain information about what was entered wrong. So in this case, I would return that the object with SSN property, which means that SSN has some issues. You can wrap this function into a directive, so-called directive, and then you just add this validator right in there, SSN right inside the tag, inside the input field tag, for example. And then underneath, in this example, I'm using span to either show or hide the message that social security number is invalid, depending on if form has error. If it returns false, then the hidden is false. No, sorry, if returns is true, then not true, meaning hidden is false, and you will see the text social security is invalid. Reactive streams. It's a super powerful area of reactive programming. It is supported in multiple places in Angular 2. The router, you can subscribe to different events in routers, in forms. Event emitter that I mentioned a couple of slides ago, it's also implemented using reactive streams. Even HTTP responses, that HTTP requests and responses are treated as a stream of values. There is a special syntax for async pipe to simplify subscription. And for example, if you want to have a WebSockets connection and the server pushes data to you through a WebSocket, you can subscribe to the data in a standard way as reactive streams prescribe. If you want to arrange some state processing, so any application may have a state, right? You have multiple components. You can create a service that remembers the state of the application, and components 1 and 2 will have the state service injected. They can subscribe to events, and they can understand when the state of your application changes. Communication with the service via HTTP protocol can be done as shown on this diagram. Say you have some web server. It doesn't matter which technology do you use for server, Node.js, Java, .NET, Python, you name it. If you can create a web server in this technology, you can use Angular on the front. And the Angular application would have the following structure. You have a component, UI component that the user can see. The service is injected into your component. The service is a class with the business logic of your application. HTTP object that Angular offers you injected into service. So technically the service through HTTP object communicates with the web server, gets the result, and since it's injected into component via bindings shows the results on the screen. Here's an example of again this sample auction application. For example, you have product service that gets data from the node server, and the product service also needs HTTP object that is injected. DI is for dependency injection. The product service in that auction application is injected into 3 components: home component, search component, product detail component. Each of these need this service to get products. So the entire logic for data exchange with the server is implemented in product service. On this diagram, you see that you can be pushing data from the server. Say in your auction, many users can bid on certain product. If you are bidding on this product and you want to know what are the latest bids on the products by other users, you can arrange that, and the server can push the notification to you, to your application. So you can have, again, client, Angular client. You will write the servers, which will be a wrapper for WebSockets, and you establish connections between the server and your WebSocket service. The server is pushing data, the service gets them, and this service is injected into your component, and as soon as the socket pushes the data, your component gets UI refreshed. All this can be done. Now, deployment. How do you automate deployments? Of course, we want to be able to write scripts that will perform several tasks when we are about to deploy. So what are the tasks? For example, remove the output, the content from the previous deployment in certain directory, create a new one, do the build, copy the file into the server. All this can be easily implemented using npm scripts or gulp or grunt. In this case, I show you the npm scripts. For example, this is a build command. I can do ng build prod, build from the bundles and make optimization. Also, I have another command called post build. npm scripts are smart enough to see, oh, I have this command and I have another command which has the same name with the prefix post. It means that the npm script will automatically execute this command after the build is over. In this case, it sees post build means run the deploy command. It'll see where is the deploy command. It's over here. But there is a command called pre-deploy. Right? Pre means run this command before the command with the same name. So it'll run the pre-deploy. In this case, it removes the content of this particular directory in the server, makes a new directory, and when this part is done, the deploy command will copy files from your this directory to the server. So the entire build and deployment was done in 4 commands. And finally, the UI. On this slide, I show you an existing site that was designed in 1995. It's one of the sites in Norway. And this site is still alive. Back then, people didn't even think about what is the proper design of the site. All these, look at all these colors and layouts and everything. It is crazy. So after a while, people started to say it's not a good idea to create such sites that are hard even to follow. And there's an effort called material design. It's technically like a visual language of specifications that defines classical principles of good design. Google leads that as well. In particular, they give you so-called palettes. So if you are not a talented designer, if you are a regular developer, you don't know which colors go well with each other. So they give you different palettes. So for example, if you want to take this as a primary color, this light blue, you can consider other colors like these that go well with it. They give you a tool to select primary color, primary palette, accent palette, and so on. Accordingly, Angular team decided to create a library of UI components that comply with this material design standard. And there is a library called Angular Material 2. As of now, it's still in beta. It has like 25 components. And these 25 components are already readily available for you to make your application looks nicer and more modern, so to speak. If you will need more components, 25 is not enough, you can look elsewhere. For example, we use a really nice open source library called PrimeNG. That library has 70 components or more, so you can find additional components that you need over there. And the last quick demo I want to show you how we can, a demo that uses some of the Angular Material 2 UI components. In this demo, I will run it actually. It consists of two parts. The server part. This is a separate project for the server. In this case, I'm running Node server on port 8000. And I already deployed the client, which was a separate project. This project is Angular project that also uses the Angular Material 2 UI components. So I started that server on port 8000. Let me bring the UI, the browser again here. So what I will do now, I will do localhost 8000. Load that application, and this UI uses some of the Angular Material 2 components. For example, this is a nice little menu with nice icon. Over here, if you will click on the input field, it's automatically moved like this, the title. When you start entering, it can show you the validation message underneath. Categories is like a little nice pop-up. The button with icons, all these little things matter, and they make your application look nicer. These are so-called cards, a card element that can that makes things stand out on the UI. So gradually you can take any application, even if you already have some Angular applications that are not using Angular Material 2, what you can do, you can start adding replacing components, standard HTML elements with components from Angular Material 2 library. And you don't have to do like either everything is done using Angular Material 2 or not. You can take components a la carte. Take one component and use it. So this is basically concludes my presentation. I wanted to tell you, and if you have any questions, I'll be happy to answer.